All right, now we're going to factor a sum or difference of cubes. Okay, so these will always come in the form of two terms. So two terms, a cubed plus b cubed, or a cubed minus b cubed. There's the sum or difference. Okay, they basically factor the same way except for the signs will be opposite in each one. Okay, so they factor into a binomial, so that's two terms, times a trinomial, three terms. All right, and the pattern holds the same every time. So that's a, b, a squared, a times b, and b squared. Okay, and that's going to be true of both types over here. So same thing over here. A, b, a squared, a, b, b squared. So the only thing that separates these are the signs in the middle. So the signs go like this. For this one, you have a plus and a minus and a plus. For this one, you have a minus and a plus and a plus. So you see those first two signs are switched in each one. Okay, the way that you can remember this, there's a little acronym. It's called SOAP, S-O-A-P. That's true for both of these. All right, S stands for same sign. So plus and plus, minus and minus. O stands for opposite sign. So opposite is a minus, opposite is a plus, and AP go together, stands for always positive. All right, so let's try a couple examples here. So how do we know what A is? How do we know what B is? All right, that comes from these. These will always have to be perfect squares, basically meaning I could break these into 3 equal parts. Okay, it's going to be very beneficial for you to kind of memorize a few of your perfect cubes beforehand. Okay, so 125 is a perfect cube. That's 5 times 5 times 5. 5 cubed equals 125. Okay, and then D cubed is a perfect cube. D times D times D. Okay, 8 works the same way. 8 is 2 cubed. So 2 times 2 times 2. So A equals 5D and B equals 2. All right, let's plug this into our little formula. All right, we've got A goes here. Same sign, minus. 2 goes here. Next one's A squared. So it's a little tricky when you have a couple of things. So 5D squared, you have to put it in parentheses when you do that, because it's going to be 5 squared D squared. So that's actually 25 D squared. That's what we're going to put here. Opposite sign, so plus. Multiplying together, 5D times 2 is 10D, always positive, and then 2 squared is 4. All right, this next one over here, you'll notice that the two exponents are not perfect cubes yet. So we can't just jump straight into going to the parentheses, but if you notice, they share things in common. They have a GCF. Okay, so I can take out, they both are divisible by 2, and they both have an x squared. So I'm going to take out a 2x squared. Okay, that's going to leave me with an x cubed on that one, and a minus, and 16 divided by 2 is 8. And then we took out the x squared, so just x cubed minus 8. Now what's left over here is a difference of cubes. So I can break this down. That's x times x times x. This one is 2 times 2 times 2. So A equals x, B equals 2. All right, don't forget about your GCF in your final answer, 2x squared. Then that's going to be x minus 2, A minus B, times x squared plus 2x plus 4. A squared plus AB plus B squared. All right, so that's sum and difference of cubes. Another type you're going to see is a difference of squares. Okay, so I've got 3 examples here, then we'll talk about this non-example after we're done there. Okay, a difference of squares is basically the same as trinomials, so what we went over on our last couple videos, with the middle term equaling 0. So it's like z squared plus 0z minus 4. So basically, you'd be looking for what numbers multiply to equal -4 and add to equal 0. Well, -2 and +2 would do that. And that's how these differences squares work. So this is z plus 2 and z minus 2. All right, and then you can apply that pattern to other more difficult types. So this one would be 9n squared plus 0n minus 16. And this would be a little harder because we'd have to multiply the 9 times 16, which is a pretty big number, and then figure out exactly what two numbers work. But if you apply this pattern, 9n squared is a perfect square, 3n and 3n. All right, I really should go back to this one. So z squared on this one was z and z. 4 was 2 and 2. So z plus 2 and z minus 2. So this is 3n and 3n. 16, we know that one is 4 times 4. So we can apply this same pattern, 3n plus 4 and 3n minus 4. All right, and if we went through the whole process like we did trinomials, we would have come up with the same thing. All right, but we can kind of shortcut it by noticing that they're perfect squares. All right, this one adds a little extra to it. So we see that these are perfect squares. X to the fourth can be broken into x squared times x squared. 16 is 4 times 4. So that's going to be x squared plus 4 and x squared minus 4. All right, but what it's left us with is actually another difference of squares. And we've actually already done it. You see it over here, z squared minus 4. Now it's with an x instead of a z, but there it is again. X times x and 2 times 2. So that's going to be x plus 2 times x minus 2. All right, and let's talk about this non-example here. It's actually the same thing that we have in this problem. Okay, you cannot factor x squared plus 4. That's not a difference of squares. Notice the word in the problem is difference, not sum. Okay, so a difference of squares means it has to have a minus sign. It can't have a plus sign. And the reason for that is if we put in a 0x there, okay, we'd have to find what two numbers multiply to equal 4, positive 4, and add to equal 0. Well, there's not one. You got 1 and 4 and 2 and 2. And for that to multiply to be a positive 4, they have to both be positive. Well, that equals 5. This one equals 4 when we add those together. Neither of those work. So that's why a sum of squares isn't a thing. You can't factor that one. So when you get these that kind of double factor like this one did, you always leave the plus sign alone. You can only do the one with the minus sign.